My name is Vincent Laudato Beltran, and I'm an associate scientist at the Getty Conservation Institute. I'll be speaking about work we've done in the GCI's Managing Collection Environments initiative to expand the typical analysis of temperature and relative humidity data to support decision making. TNRH represent 2 of the 10 primary deterioration agents for heritage objects, and the collection of this data is common in cultural heritage. This data is intertwined with many museum priorities, including collection conservation, human comfort, and the performance of the building envelope. TNRH is also the focus of many environmental guidance documents in cultural heritage, including BS EN 16893 and the ASHRAE chapter on museums, galleries, archives, and libraries. While the analysis of TNRH data is most conveniently carried out using data logger software, such practice can sometimes overlook information that is present in the dataset. By furthering our analysis of TNRH, the collection care professional can gain a deeper understanding of the museum environment, improve communication with stakeholders with varying expertise in environmental data analysis, and ultimately support decision-making that can lead to more sustainable practice. Today, I'll talk about 4 activities that exemplify the GCI's exploration of environmental data analysis. These include an MCE course called Preserving Collections in the Age of Sustainability, a recent ICOM-CC paper surveying TNRH analysis tools, a GCI organized meeting bringing together colleagues from different disciplines to discuss the state of the field with respect to environmental analysis tools, and GCI workshops to begin sharing of this information with the conservation community. We'll begin with the GCI's MCE course on sustainability and the didactic tool that emerged. Developed by my former GCI colleague Joel Taylor, this course combined various disciplines and skills to help build consensus on appropriate environmental approaches for cultural heritage. The range of topics for the 2-week intensive workshop ranged from the building envelope and object response, environmental monitoring and data analysis and visualization, and skills such as negotiation, influence, and consensus building. I was given an opportunity to teach about monitoring, analysis, and visualization, and one of the components I developed was a didactic tool called the GCI Excel Tools. This was based on data analysis I had conducted over a number of years with the late Shin Maekawa in the GCI's former Environmental Studies Laboratory. Through the GCI Excel Tools, I wanted to present to the course participants a framework of TNRH data analysis that went beyond that provided by data logger software, while using software that was widely accessible and used. So what are the GCI Excel tools? They consist of 5 modules, with the first dedicated to the input of TNRH data and subsequent calculations for humidity ratio, dew point temperature, and 24-hour and 7-day moving windows. Data and calculations from this module are then input into other modules, which focus on various visualization types. Time series are the most common plot type, but here we try to overlay different types of information to more clearly convey the message. Cumulative relative frequency and box plots show probability within the dataset in complementary ways. Finally, plotting of the data on a psychrometric chart allows one to examine the TNRH data together, while connecting data that is outside of your specified conditions with potential psychrometric strategies to bring these parcels of error within your target zone. These tools gain traction with the course participants upon return to their home institutions, and I myself use them often to quickly examine environmental data. In addition to expanding their own understanding of the museum environment, the GCI Excel tools help the participants facilitate communication about the environment with both technical and non-technical staff, and aided in defining and prioritizing their environmental management approaches. We'll next discuss an ICOM-CC paper written with my colleague, Annelies Cozert, formerly at the GCI and now at KIK-ERPA in Belgium. Following up on my development of the GCI Excel tools, Annelies and I wanted to explore different environmental analysis tools with the idea that multiple complementary tools can improve understanding better than any single tool. We conducted a survey of collection care professionals about their analysis of T and RH data, as well as a survey of free or inexpensive conservation-focused data analysis tools, including the GCI Excel tools, eClimate Notebook by the Image Permanence Institute, the Physics of Monuments tool by the Technical University of Eindhoven, Harry E. by the Jersey Haber Institute, and Conservation Physics by the late Tim Padfield. The ICOM-CC paper organized these tools by themes of use identified from the survey of heritage professionals. These themes included alignment with standards, addressing risk, mechanical strategies and energy use, and communication. We then created a summary table shown at left, comparing these 5 tools in terms of capability, data input and outputs, and available visualizations. We also included comments which highlighted their individual strengths. In our discussion section, we shifted to a summary of the recommended characteristics sought after by our surveyed participants in a successful tool, which provided a bridge to our next activity. The next effort was a meeting organized by the GCI to discuss lessons learned and future development of T and RH data analysis tools. Convened in December 2019 at the Winterthur Museum, this meeting brought together both tool users and developers from a range of fields, including conservation, engineering, architecture, data science, and building physics. The goal was to discuss the state of the field with respect to environmental data analysis tools and how we might define a framework to support their continued use and development. At the end of the meeting, the participants committed to creating a document summarizing the discussion and with hopes of furthering the discourse on preventive conservation analysis tools. Slated for publication by the GCI near the end of 2021, this document is organized as follows. Since it is positioned at the intersection of multiple disciplines, we first wanted to define the perspectives of the different players with respect to environmental data analysis tools. These include collection care professionals, conservation educators, engineers, and computer scientists. This is followed by chapters on the fundamentals of data analysis and visualization and the state of the field. We then discussed the benefit of integrating T and RH data with complementary datasets and the need for dissemination, education, and collaboration. Finally, we examined possible collaborative paths toward the development of discerning and intuitive tools. Discussion at the Winterthur meeting clearly emphasized the need for training on these tools, so Annelies and I, along with our colleague Jeremy Linden from Linden Preservation Services, sought to explore this opportunity. While I've been talking about the benefit of these tools, there are several roadblocks to their effective use, including a lack of awareness of T and RH analysis tools, a lack of training on data analysis and visualization, a lack of guidance to help users quickly gain proficiency in these tools, and a lack of demonstrations of data analysis and interpretation in real case studies. Clearly, the GCI and MCE were interested in tackling these issues, so we originally scheduled a half-day in-person workshop at the 2020 AIC annual meeting. Due to the pandemic, this workshop was shifted to virtual synchronous sessions, which meshed well due to our focus on online tools. This workshop was offered twice during the summer of 2020, and we had 72 participants from 8 countries. The workshops were organized into the following 4 sessions: Fundamentals of Data Analysis and Visualization, a survey of online tools, case studies, and an open discussion forum. Each session was separated by 1 week to allow for practice using the tools, virtual office hours, and individual guidance. We plan to reprise the workshop in 2022 with KIC-IRPA and are seeking regional partners elsewhere in the world, with an eye towards Central and South America and Southeast Asia. Simultaneously, we are planning an asynchronous version of this tools workshop. This would allow us to freely share this information on the Getty website without restrictions of time and place, and would provide equitable access to colleagues with varying experience levels and economic constraints. So now, a quick glimpse into the future. Moving forward, we will continue our efforts to develop didactic resources for tool users, which includes collection care professionals and allied fields such as registrars, facilities, and engineers. We'd also like to renew our relationships with tool developers, including the Jersey Haber Institute, the Victoria and Albert Museum, the Beam Lab at Penn State University, Image Permanence Institute, and Conserve. The hope is that we can collectively promote the dialogue between tool users and developers to align their goals and strategies. As always, this work is the culmination of discussions and activities by a group of talented people. So I wanted to close by acknowledging the GCI and MCE colleagues, past and present, who have made this effort so worthwhile. Thank you for your attention.